do it with Pascal's triangle. So that means that I start with what? The third row of the triangle, which is, what, do you have those numbers memorized maybe by now? You certainly don't have to. But what is the third row of the triangle?
1, 3, 3, 1.
Yep. And I have an X and a -4. And my powers, starting with the 3 here, and then simplify. So remember, anything to the 0 is 1, so I have x cubed. Be careful, minus 12. Plus 48. Minus 64. Is that what you got, Jordan, when you did it by hand?
Yeah.
Perfect. Everybody good? No problem. All right. What is the degree of the polynomial in number 2? The degree of the polynomial would be 6. Everybody okay with that? What would the leading coefficient be? Wouldn't it be 2? You got a 2x out there in front. So you're going to take your 2x times x, or 2x times x to the 4th times x. So it's going to be 2. What is the constant term of the polynomial? What do we mean by constant term? The one with no variable. So like the y-intercept. What's that going to be? What's that y-intercept going to be?
810.
No, that'd be 10.
I got -30.
No, but I understand where that came from. That 3 is being to the 4th power, guys. So that 3 right there stands for 81.
-810.
Okay,
Or positive
13.
we would be multiplying a -5 times an 81 times a -2, 810. All right, make sure that makes sense to you guys. We're not talking about any of the middle stuff. We're talking about what would be that very last number. And that would come from multiplying the -5 times the 81 times the -2. All right, Kelly and Rowan are going to write x plus 2 to the 4th. Kelly wrote this, Rowan wrote this. Which are correct? Well, I don't know. What would my coefficients be?
1, 4, 6, 4.
So I know right away that Kelly's wrong. How do I know right away Kelly's wrong?
Coefficients are.
Yeah, the coefficients she has are 1, 4, 6, 4, 1, and that isn't what these coefficients are going to end up being, because what am I going to have in every term? A multiple of 2? You see what I'm saying? Because of the 2 in there? Alright, so let's see, is Rowan gonna be right? I don't know. First term's clearly x to the 4th. What's our second term gonna be? 8x to the 3rd, is that what he's got? Yep. How about our next one? 24x squared. Rowan looks like he knows what he's doing. 32 and 16. Yep, Rowan's right. Would you agree with that? x plus 2y to the 5th, there's a term that has an xy to the 4th in it. That makes sense to you, right? We're gonna go down the line and something's gonna have an xy to the 4th. And we want to know what would its coefficient be. That's the 5th row of the triangle. Where is the xy to the 4th term in this list? Right there? So whatever I got, my coefficient's gonna be 5. And I got a 2y. So can you tell what that coefficient will be? It won't be 5. It starts out 5, but you've got this 2y in there complicating it. So what is the coefficient really gonna be? 16 times 5, so it's gonna be 80. Everybody good with that? Alrighty, guys, now I got some stuff. I think it's gonna be easier if I just have you guys come up and get one. I got 3 things. I need you to come up and get one of each. So everybody quickly come up and get one of each.
Lauren, you want to get you one?
And then I want to explain to you what you just picked up. So everybody gets one of each. So this thing, this single sheet that's called Big Ten, it has 10 problems, at least I hope. 3, 4, 5, 6, 7, 8, 9, 10. It has 10 problems. And the answer to each of the problems is the digits 0 through 9. So the answer to one of them is 1. The answer to another one is 7. The answer to another one is 8. Use each of those one time if you're working through this, all right? Then this thing that says review topics 1-1 to 111, we're going to spend a couple days reviewing, and then we'll have a quiz over 1-1 to 111. And this is the review sheet I put together as I was writing your quiz, okay? So this will kind of be our focused review right here. And then I found all of Mr. Passwater's like extra worksheets and stuff, put that together in this packet here. I did this last time, if you remember, and we didn't have time to do nearly all of it, and we don't have time this time, but it's a place for you to look for either extra practice or to signal, oh gosh, I don't remember how to do that problem. All right, so today we're gonna start with the Big Ten, because it's kind of a fun exercise. So we'll do some together, and then next time maybe we'll finish up on our own. But let's look at number 1. How do we figure out where there's a hole? What do we have to do? Factor it. Sure, gotta factor it. And what are the factors? On top I have, 6 and 7? And on the bottom, I have 6 and 5. So where's there a hole at x equals 6? Now, for purposes of this problem, that's all you need, x equals 6. If we were graphing it, then what would you need to do if we were actually graphing? You'd plug in 6 here and get, I think, -1. and that would be where I'd plot the hole, but here it's x equals 6. Okay, so now you can cross 6 off of your list. You've already used that one. All right, where's the horizontal asymptote for B? 0. Y equals 0. Why? Because the power on bottom is bigger. The asymptote's going to be at 0. All right, we can cross off 0. How many vertical asymptotes does this have? Now, be very careful. What's your gut feeling? 2. Because you got an x squared in the bottom. But kids, what do you have to do? Before you just say 2, you have to do what? Factor the bottom also, or the top also, I mean, because what could happen? You could cancel, and then you wouldn't have 2 asymptotes, you would have only 1. Well, does anything cancel? No. So there were 2. 2 is correct. Find the vertical asymptote of problem D. Okay, so the bottom I can factor. The top, I'm gonna have to take a 2 out. Don't let me go too fast. Are you guys with me? I'm gonna take a 2 out of the top. And that's gonna leave me with x minus 7 minus 1. So this is what I was talking about a minute ago. It looks like you're gonna have 2 vertical asymptotes, but you're not, are you? You're only gonna have 1, and it's at x equals 8. We okay? All right, h of 5. Oh my gosh, that's like algebra 1. How do we find h of 5? Plug it in. So if we plug it in, what do we get? 25 plus 10 minus 15 over 25 minus 20. Yep, 20 over 5. That one's 4. This guy has a hole at C and a vertical asymptote at D. Find C plus D. How do we factor here? X plus 11 and 2 and x minus 11 plus 2. Check my arithmetic, is that right? So I have a hole where x is negative 2. And I have a vertical asymptote where x is 11. So adding them together makes 9. Oh, Lord. Oh, okay. Horizontal asymptote. That's easy. Where's the horizontal asymptote? 3. Y equals 3. A graph is shown along with all the asymptotes. Find the limit as x approaches negative infinity. The limit as x approaches negative infinity is 1. 1. Where's negative infinity? Left side of your picture, right? Correct? And what's happening to the curve? The farther it goes to the left, the closer it gets to 1. If all this here is a rational function that has a hole, then which of the following could be the value of C? It would have to be 7, wouldn't it? Okay, who's been crossing off? What does the answer to the last one have to be? 5, let's see if it is. The function has a horizontal asymptote of 4. Find the value of A. It would have to be 5. Right? Well, that didn't take us very long. I'm going to stop there anyhow. That's awesome. Thank you. What I want you to do now, I already assigned 1.11 homework, right?
No.
No? All right, consider it assigned, and it will be due on Friday.
Peace out, beloved.